Just as a quick note before this video starts, the goal of this project is to take an ordinary laptop and make it into a bit of a gaming beast with only the minimal amount of cost and while keeping it as portable as I possibly can. Now of course I am going to lose a little bit of portability with this kind of project, but the idea is to try to still keep it as portable as possible while still keeping the cost down and using some leftover parts from a previous rig. So hopefully you guys understand where I'm coming from with this. Links to everything I have in the video in the description. Also, as far as the graphics card dock goes, this is version 7.0 that I have. They're on version 8.0. There's not much of a difference between the two other than there's a shield over the top of the ports. So hope you guys enjoy and let's get into it. Alright, so what's up everyone? Inside this box in front of me, ignore the mess that is my desk by the way, is a project that I was supposed to do a video on over a year ago, but because of constraints and other things, school kind of got in the way of it. I never actually ended up going through with it. Now, the inspiration for this project kind of comes from a couple of different YouTubers, Tech Yes City being one of them, the other one also being DIY Perks. I kind of like doing these styles of videos, so let me know what you guys think in the comments down below. But pretty much we're going to be using what's inside this box to take an average standard laptop that you can get anywhere and turning it into a gaming machine. Now obviously this isn't going to be just dedicated as a gaming machine, but it can do multiple things. So the first thing that's inside this box, by the way, is the dock itself. But also this doesn't only take graphics card, you can also hook up any sort of PCIe device to it, and pretty much yeah, it'll work just like that. You'll also need to supply power, so I'm going to be building a separate power supply for it in this video. So pretty much it uses an HDMI cable to connect data to it, but it also has this 12 volt pin jack on one end and the 8-pin power connector thing that you need the adapter for, and it also has a 6-pin adapter which can split into a 4-pin and an 8-pin and a 6-pin, sorry, for most graphics cards. Now I'm going to be setting this aside for now, but I'm going to be using the 8-pin adapter because it takes out the 100 watt limit that you would have with the regular DC jack. So there's that. And yeah, that's about it. So the next thing in the box are a couple of cables that you get with the thing itself. So the first cable you get pretty much is a 20-pin and 4-pin adapter that goes into an 8-pin adapter. Now that goes straight into the dock itself. Now something weird I noticed is that if you don't have one of those Dell 8-pin power supplies, it doesn't supply the USB. So the next thing is the PCIe to HDMI adapter. I put a do not use label on it so no one plugs that into the, anything that would, you know, be like a TV or something like that. You don't want to do that because if you do, you actually would probably fry something and I don't want to find out. So yeah, that goes into the dock itself, and then the other end will go into your laptop. More or less likely most laptops only have one adapter in them, so you're most likely going to be taking out your wireless card. If that's the case, I'd recommend getting a little USB dongle like this one, and that should do the trick. And I believe that's about it. Yeah, so you plug that guy into your laptop, you'll take out your wireless card, and that will then supply data to the dock. So the next thing inside the box would be this cable here. This is the cable that goes into the side, and that also splits into a 8-pin and a 6-pin for the graphics card. So that plugs into the dock like so, and then the other end, also those two ports are what you're going to be using for power, and the other end will go into your graphics card. Alright, so now that we got all that out the way, I'm going to be showing you guys what my laptop that I'm going to be using is. Also I think, let me see here. And for the graphics card, I'm going to pull it out now. It's a 750 Ti. It's a super clocked edition from EVGA. It's a good card, served me well. Most games they'll be able to play at medium to high settings at 1080p. It does have a 2GB frame buffer, so you're not going to be doing any sort of 4K gaming. But for my purpose, it's going to be great. So this is the card that I'm using. It served me well, so I did use it to record in my earlier rig, or my previous rig. And that just plugs into the dock, and you plug in the power, and that's about it. And now I'm going to show you guys the laptop that I'm going to be using. I don't know the exact model of it, but it is an HP machine. As you can see, I decked it out with stickers. Don't know why, just felt like it. So yeah, pretty much it has an i5 in it. It's not necessarily a quad-core i5. It's also one of the laptops with the shitty Beats audio on it. Didn't buy it because of that, bought it because it was on sale for Black Friday. And it has an i5, which is dual-core i5, which is hyper-threaded. Would have preferred if it was quad-core, but it's not really going to mean much of a difference. in terms of game performance. Well, a little bit, but not much. So it's not really a big thing that I'm concerned about. And yeah, so let's get right into it. The first thing we're going to do is disassemble the laptop. Now, I kind of lost a lot of the footage. I don't know what exactly happened to it with me disassembling the machine. So I'm kind of going to, you're going to see a bit of a jump. So I'm just going to cut ahead to where I already had installed the thing inside the laptop. Sorry, I wish I could have showed you guys, but I have no idea where the flipping footage went for that. So pretty much what I am going to show here is a battery pack which I've made from an old laptop battery. It's going to come a little bit more closer to frame now. I tried charging it, but the thing literally would not hold a charge anymore. So that pretty much means it's dead. It's really no reviving lithium batteries. And I ended up powering up the dock for the first time and it didn't really work. Now, be wary of this if you have a laptop as well, because a lot of the times if this doesn't work, one thing that will do it will usually be a BIOS update. Another thing could be if you have 2 sticks of RAM installed, you should get rid of 1 stick of RAM. I don't know why specifically that's an issue. I think it has to do something with the way laptops allocate resources and things like that. So if you have 2 memory sticks and you notice the graphics card powers up and Windows doesn't detect it at all, like it doesn't show up in Device Manager, it could be that you have 2 sticks of RAM in your laptop, which I found out to be the case with mine. I forgot that I had put an extra stick in, and when I was reading up on the documentation for this dock, it said try removing a stick of RAM, and that seemed to do the trick. I don't know why or how or what exactly, but that's my sort of guess. And the next thing we're going to do is actually clean the graphics card, because I haven't done that. So I'll cut ahead and sort of just fast forward the footage of that, because that's boring, you know, no one wants to really see that. So pretty much here I start disassembling the card, and I turn on the light to sort of act as a fill light, and I disassembled this entire 750 Ti. I took everything out, I cleaned it, put it back together, reapplied the thermal paste. For some reason, I don't know why I originally removed the thermal paste, but I was testing some things and I guess I never really put more back. As you can see in this image, there's none on the heatsink or on the card. So pretty much in order to clean these sort of fin style heatsinks, it's best to use some kind of dish soap, and that would do the job really. Just rub it across a bit and then run some warm water through it. You don't want to use any high pressure water because that could bend the fins. Alright, so now what you're looking at is a power brick. Well, not a power brick, it's a regulator that I ordered to help run the graphics card, which you see there. And what I'm going to do basically is I'm going to take this old 4-pin adapter that I chopped off a dead power supply, plug it in that pretty much, and wire it up through the power regulator. Now, something that I noticed is that my power brick that I have currently only puts out about 19 volts. Now, do not try to run your graphics card on anything higher than 14 volts. I've tried it. Anything higher than that literally fries the card. I fried an R7-240 on 19 volts. Also, here is the power regulator's input and output label. It takes up to 24 volts. You can run it at anything lower than that. I noticed the thing's a bit smart. It's able to sort of readjust itself on different voltages. So what I'm going to be doing is I'm going to wire it up to that laptop brick, which I also got off of eBay. Both of those things cost around about $10 to $15 depending on which seller you get it from. But yeah, you can get both of these things on eBay. I'll have links in the description down below. I'll also have a link for the dock in the description. And pretty much the power brick will put out about 19 volts at 6 amps. And the power regulator that I ordered can put out around about 10 amps on 12 volts. So they're both obviously a bit overkill, but it should get the job done anyways. So the next thing we're going to want to do is we're going to try to figure out how we're going to mount the giant massive heatsink thing onto the power brick. Now the idea of this, as I said before, is to get it as portable as I possibly can, and to make sure everything can fit into basically my laptop bag. Alright, so the first thing I'm doing here is I'm actually measuring out the length of the cable that I want for the input, and pretty much I kind of end up cutting the laptop cable and fitting it to size. And pretty much in this next scene here, I'm using a multimeter hooked up to the lead outputs of the brick, the power brick, because I actually don't know what the polarities was from the last time I checked. So if you don't know what the polarity is on your power brick, since they use like very unconventional color combinations or color coding, do get a multimeter. It'll help out a lot. And so what I do here actually is I plug the thing in and let it turn on for a second or two. When it turns on, you'll see the light turn green there. And here pretty much I pick up the multimeter to show you guys that it's hooked up, and that by luck of chance I managed to get the polarity right. So brown is positive and blue is negative. And from here I unplug the charger and just charge it. Also, since these things actually have some pretty big capacitors in them, they kind of stay on a little bit even after you turn them off. So what I do is I usually touch both leads together. It doesn't make a spark or anything when it's unplugged, it just kind of kills it. So you want to just charge it before you actually start working on it, so that we don't have sparks flying when you touch the wires together and stuff. So yeah, pretty much the color coding on this is that red and black are for the outputs. No, sorry, red and black is the input and yellow and black are the output. Now, for a quick sort of note on color coding on a power supply, a PC power supply at least, black is usually ground and yellow is usually positive 12, so you know that's pretty much that. And it's as simple as that really to hook everything up, and then we just start soldering things together and cutting things up. I'm gonna set this back on there, get the flux, cover these guys both in it, like that, and like that. Pull this back like that. Alright, get in both of these guys. Like that. Now we're going to run a test for this guy. So red and black are the input and black and yellow is the output. So I'm going to wire them up like this. So brown was positive, so that's going to wire up to this guy. Need to put some more solder on the iron. Alright, so at this point, pretty much I wired the thing up for a test run, and I'm going to show you guys the multimeter now, and as you can see, it works a straight 11.97 volts, which is practically 12. It's a little bit under by like 0.3 volts, which doesn't really matter. So as you can see, everything's wired up. Now what I'm going to do is I'm going to try to shorten down the lead off of the charger and reuse that shortened bit. So what you want to do is you want to cut that guy down that I'm holding there, and don't throw away the extra bit, because I'll show you what you do with that afterwards. So pretty much at this point I begin to desolder the test leads, and then I start shortening everything down to make it look nice, and I'll skip ahead to the part where I actually start cutting up the charger wires, and I'll show you guys what I do from there. Alright, so what I do here is I basically take the leads from the power regulator, kind of lay them onto the leads of the charger, and just take a rough estimate and kind of cut a little bit more than I need, so that way, you know, you can never be too sure about the way your wires are. And this extra lead here that you have left over, do not throw that out, keep that aside. Alright, and the next bit that I do now is I start stripping the wires and preparing them for being soldered. So what I do is I strip them down, pull off the fireproof coating on them, and soak them in a bit, not really soak, but dip both wires, the exposed copper ends, into a bit of flux, and then tin them with some solder. And then from there I solder them onto the power regulator's input, and we'll go from there. Also, pretty much what I do here as well is I also do trim down the leads on the power regulators, and I retin those because they use some really weird, I think it's like lead-free solder or something on it, and it's like for some reason it's crazy hard to melt. I don't know why. It could just be the thickness of the wire, but I retin them, and that seemed to make it a bit easier. So right here I'm measuring out how much I would need to cut off, and I just take a rough estimate and then cut it with a pair of scissors, and then we go from there. So I don't know when and where the camera died, but apparently it did, so I'm gonna have to redo some of the stuff I said. So I already got this bit soldered on, as you can see. Now the next thing to do is, I've already checked that it works and that's good. So next thing to do is to reuse that piece of wire from this end that I told you guys not to throw out. And I kind of cleaned up the solder joints a bit, even though it's kind of dirty because this is a really thick wire. So what we're going to want to do is we're going to wire this up, right? Using the sort of same color scheme here. So if you don't know power supply wiring, yellow is positive and black is negative. This is 12 volts and this is ground. And if it was a power supply, this would red would obviously be 5 volts, black is ground. But because this is a regulator, it uses a red as the input. So we're going to grab this guy and we're going to attach the brown wire to here. Also, you want to make sure you have a bit of a solder on the iron because mine doesn't. So I'm going to grab that and just attach it like that. So for some reason my camera keeps deciding whether or not when it wants to stop recording, so I soldered this up, and now we're going to use this end, which is going to connect to this guy, which will then connect into that. So once we do all that, we'll do a test run with this laptop, and I'll show you guys some cool things you can do with that. So I'm going to pull this in, dip some of that in that, dip some of that in that, and I'll start turning it. I think my camera might be overheating, not too sure, because it keeps stopping the recording for random reason, like no reason whatsoever. So I don't know what's happening there. It is pretty hot out today, so I'm not surprised if it is overheating. I'm gonna turn this guy like that. Okay. And turn this guy like that. Okay, I'm gonna set this back down here. Like that. Make sure you're still recording. Yep. Wipe the excess flux off of this. And what we're gonna want to do is we're going to strip both of these, tie them together, strip both of these, tie them together, and then solder them onto here with the correct polarity. Again, yellow being 12 volts, negative, black being ground, or yeah, just black being ground. I don't know why I was going to say negative there. That's not correct. So pretty much you're going to wipe the flux off of this. Then we're going to solder it based on the color coding, so brown being positive and blue being negative. So grab this, I'm going to solder it like that, so that way it sticks out, because if you do it like this, it's going to bend backwards and you don't want to do that. So let me grab the iron, put that there, grab this guy, put more solder onto it, grab this guy,
and I don't know how specifically I can do this, but hopefully the camera can see what I'm trying to do. So brown is positive, so I'm going to go with that yellow, like that. I'm going to gently blow on it so it cools down pretty quickly as well. And then blue being the negative, so I'm going to you don't want anything conductive getting in the way of this. Also, we can kind of move this out the way so nothing touches that. Last thing you want is scrap wires going into an outlet. Alright, so I got a bit of melting from the flux on the desk. Alright, now what we want to do is make sure the camera's still recording. Oh crap. That came out. Shit. Oh, no worries, I'll fix that later, but now what we want to do is we want to plug this guy in. Or actually, I need to shut down the laptop first to do this, because I can't do it while it's running, so. Let me see if I can get the camera pointed at that, so I'm going to shut this guy down real quickly. I'm also going to do one more test run of the power supply to make sure it's actually putting out 12 volts, as I said. Reason why I'm using the power supply adapter is because I noticed all the wires are yellow and the pins are flipped when you plug it in there, so I don't want to fry anything. So I'm just gonna double check the polarity on this guy to make sure it's right. Set my multimeter onto 20 volts and plug this in one-handed somehow. Yeah, okay, so the polarity is correct. Shit. Alright, so I forgot the laptop was powering the camera, so when I turned it off, I turned off the camera. But pretty much everything's wired up, and when I plug this in, it turns it on even though the laptop's off, so that's interesting. The next thing I want to do is want to check device manager and see if it actually comes up. Under display adapters. Hey, there we go. Look at that. Look at that. Let's see if we can get the zoom in on that. The flickering may not help, but autofocus is crap because of the flickering, but it actually shows up. So the next thing to do is to see whether or not this guy will actually run. So interestingly enough, when you go into the NVIDIA control panel, I don't think the camera's going to pick this up very well, but I'll see if I get some screenshots I'll put in there at this point. In the control panel I can set which GPU is being used. Now here's the part that I'm a little bit confused about. Someone, if you know how circuitry wise how Intel CPUs are designed, because apparently there's a pass-through. There's an option that lets me use the GPU right on the laptop display, which I thought, right, because most laptops now have dual GPUs in them. They'll use the Intel GPU on battery and the external GPU, or their NVIDIA GPU or the AMD GPU on powered when it's plugged into the outlet. Which is really weird because, you know, I thought that was a circuitry thing, that was wired in certain laptops to work that way. But it turns out that it isn't. So if I launch Heaven Benchmark right now, it should work just fine. So let me put it in benchmark mode. And I think that's all that's left to do with this, is to put it in a nice case and make it look good. Make that power supply actually isolate the wires so they don't short, and mount this heatsink brick onto that power brick. As you can see, it works.
And yeah, here's an image of the final thing in action. I still gotta isolate the contacts and also make sure that I put the thing in a nice box, put the graphics card in a nice ventilated box. I'm gonna do that in another video for another time. But pretty much as of this point, this is portable enough so you could throw it in a bag and take it anywhere with you. So it works, you know. I'm actually surprised that it works. So let me tell you guys a couple of things that I actually didn't expect. So originally I thought that I wouldn't be able to do that pass-through with the NVIDIA control panel. I found that out completely by accident. I was messing around with the control panel and I saw that option. I was like, huh, that actually works, and I tried it and I noticed that it worked. So my original theory was to get some sort of remote desktop kind of VNC thing going on, where I have the main display, a virtual display, on the graphics card, and then relay it back to the laptop display, which is going to be display number 2 via VNC or something like that. That worked in theory, but in practice, it really was laggy, so it wasn't worth that sort of thing. It just wasn't worth implementing, right? It was too much work, and the hassle for that to get working, it took me hours on end to get it working, and this was there, and I didn't even realize it. So the fact that this works surprises me so much. And it turns out, by the way, the 750 Ti only pulls about 60 watts, so you still have a good 20 to 30 watt headroom with this setup. So that way you could use a little bit more of a powerful card, maybe like, I don't know, a 780 or something like that, something that's a little bit more beefy, and it will still run just fine. So in the next video, I'm probably going to build a case for this and make it look nice. Also, this is my second setup, by the way. I'll have a video or some sort of vlog coming out about this setup soon. So let me know what you guys think about this setup in the comments down below. Would you try this? Would you, want to try this? If you have tried it, let me know your results. And yeah, that's about it. Thanks for watching, and I'll catch you on the next one. I apologize for this video was supposed to come out a year ago. I know a lot of you who are new to the channel would not know that, but as I said, a lot of things got in the way of me doing this video. It was supposed to come out over a year ago, but now at least it's, better late than never, and I actually got it out. I got it done. It's built, and it's golden, guys. Thank you all for watching, and I'll catch you all in the next one.